Dear students, welcome to our next fluid mechanics class. So in this class, we will start flow over notches and Weirs. Okay. So from the third unit, that means the first portion, we discuss about the application of Bernoulli's equation. We seen Venturi meter, orifice meter, pitot tube, etc. So that those type of instruments is mainly used for measuring the rate of flow in a closed conduit. That means closed conduit means pipes. Okay, a closed one. Okay, so this flow over notches and Weirs. Notches and Weirs are open conduit. That means open channel flow. Okay, open channel. It's subjected to open to the sky. But closed conduit means it is fully closed. If you take a pipe, it is fully closed. Okay, so that is the major difference. Also, the Venturi meter and orifice meters are mainly used for the flow measurement in smaller cross sections. So if you take a pipe, that is a very smaller only. Okay, so the normally the pipe diameter having 15 mm, 20 mm, 25 mm, and 40. If you take industrial pipes, it's around 300 mm or 400 mm only. But if you consider open channel flow, its dimension is more. That means 1 meter, 2 meter, 3 meter, even 10 meters also. So how to measure this type of notches and Weirs? Flow occurs, flow occurs of the water in case of notches and Weirs. How to calculate the discharges in case of this open channel flow? That we will discuss in this chapter. Okay, this is the unit 3 portion, flow over notches and Weirs. Second part, flow through rectangular, triangular and trapezoidal notches and Weirs. End contractions, velocity approach, broad crusted weir. Okay, these are all the important topics. Okay, so what is meant by notches and Weirs? So this is the introduction slide. So a notch is a device used for measuring the rate of flow. So what is the other name of rate of flow? It is nothing but discharge. Rate of flow of a liquid through a small channel or a tank. Okay, so a notch is a device used for measuring the rate of flow of a liquid through a small channel or a tank. So a weir is a concrete or masonry structure placed in an open channel over which the flow occurs. It is generally in the form of vertical wall with a sharp edge at the top, running all the way across the open channel. See, the notches and Weirs both serves same principle only. That means these devices, that notches and Weirs, both are used for measuring the rate of flow only. Okay, so now what is the difference? So the difference is based on its shape, okay, and size. So based on these two category, it's different. Okay, if the cross section is very small, we can use notches. So suppose if we take 1 meter channel or 2 meter channel, so we can place a metallic plate. Okay, that metallic plate, it's made up of metals. It is in the cross section of rectangular, triangular or trapezoidal, whatever it may be. So that is called notches. So it having a smaller cross section. But if we take weir is a large cross section. So it is not made up of metallic plate. It is made up of concrete or stone masonry or brick masonry, because the channel, width of the channel is huge, like 10 meter, 20 meter, 30 meter, like that. Okay, so for that purpose we have to construct weir. Okay, so that purpose is same, to find the rate of flow, but according to the size and shape it is different, notches and Weirs. So the notch is of small size while the weir is of a bigger size. Okay, so for that bigger purpose only we are constructing weir in concrete or masonry. Okay, The notches is generally made up of metallic plate, while weir is made up of concrete or masonry structure. Okay. So these are all the basic difference. An introduction about notches and weirs. So next, two important terminologies in this notches and weirs. First one is nappy or vein. So the sheet of water flowing through a notch. A sheet of water flowing through a notch or weir is called a nappy or vein. Okay. So I will explain in a picture in your next slide. Next, the crust or sill. The bottom edge of a notch or a top of a weir over which the water flows is known as a sill or crust. Okay. So classification of notches and weirs. So this is important question. What are the different classification is there? So the notches are classified as according to the shape of the opening. First one, there are two different major categories. First one, according to the shape. So first one is rectangular notch, triangular notch, trapezoidal notch, and stepped notch. Okay. So these are all the four important categories of the notch. So out of these four important categories of notch, first three, that means rectangular, triangular, trapezoidal notch. So first three is available in your syllabus. So stepped notch is not there. So you can leave that stepped notch. Second, according to the effect of the sides on the nappy. In that, notch with end contraction and notch without end contraction are suppressed notch. Okay, these are all the classification of the notch. Next, weirs. Weirs are classified according to the shape of the opening, comma, the shape of the crust, comma, the effect of the sides on the nappy, and the nature of the discharge. The following are important classification. So first, according to the shape of the opening, rectangular weir. Okay. So rectangular weir, triangular weir, and third one trapezoidal weir, or otherwise is called spiloty weir. Okay. So next, according to the shape of the crust. So first one according to the shape of the opening, and second one according to the shape of the crust. Okay. So sharp crust weir, broad crusted weir, narrow crusted weir, and ogee shaped weir. So these are all the important classification and the categories of the notches and weirs. So you can see in this picture, this is a cross section of a rectangular notch. So I will tell the important terminologies from this picture. So you can see here in this 3D view. So there is a notch is there, rectangular notch is there. So from this notch, water is flowing on the notch. Okay, this is the rectangular shaped notch. Rectangular shaped water is flowing in the notch. This is the cross section. If you cut here and you can have to see from this this side, means this is the end view of the notch. So water is flowing off of the opening, so that height is small h, and this is B is the opening of the notch, and capital B is the breadth of that channel. Okay, and nappy, what is by nappy? This is the sheet of water. See here, water is flowing above the crust. So this is called crust point. This is called crust point. Okay. So the bottom edge of the notch. See here, this is the notch. Okay. So this bottom is called a crust. Okay. C-R-E-S-T. This is called a crust. Okay. So and nappy is nothing but a sheet of water. That means water flowing above the crust. Okay. So it's flowing like this. So this shape is called nappy. The shape is called nappy. So you can see in this picture, we can clearly understand. So this is called nappy, and this is bottom edge of the notch is called crust. Okay. So next, what is this H? See, H is nothing but the head of water. It is called head of water. Okay, that means the distance between the bottom edge of the notch to the top surface of water. Okay, the distance between bottom edge of the notch to the top surface of the water is called capital H. Okay, so that H is called head of water. So now for derivation purpose, okay, so this is the height, capital H. So you can see from here, okay, we can observe like this rectangular portion. So from this rectangular portion, I take a small thickness of height, the small thickness of the height. Okay, so the breadth of the notch. So here L is nothing but here instead of B, I put L. Okay, so L is the length of the rectangular notch. That means that crust level. Okay, so that is L, and this is the a small thickness in the flowing water. Consider this is the thickness of the flowing water at that crust level, and this is the DH. Okay, DH. This point is the DH. Okay, the distance. A small thickness. Consider a small thickness. So now we will derive the what is the actual discharge formula and the theoretical discharge formula. So CD, coefficient of discharge of the notch. The formula is actual discharge divided by theoretical discharge. So first, as per our venturimeter or meter, first we have to derive the theoretical discharge. Okay, theoretical discharge. So if you multiply by the coefficient of discharge into theoretical discharge, we can easily get the actual discharge of the flowing water. Okay, so now let us see. So you can see here, this is the laboratory rectangular notch instrument. Okay, equipment. So this is the collecting tank. You can observe this. This is a small metallic plate, and this is the rectangular shape. Okay, so this is the channel. This length is the channel length, and this portion is the L. Okay, length of the notch. Okay, length of the notch, and this is the length of the channel, and this is the collecting tank. So water is collecting from here. This is the collecting tank. Okay. You can see here a small metallic plate is there. From that, water is flowing to measure the rate of flow. And here also water is flowing. This is the rectangular notch. Water is flowing above that crust level. So these are all the live photos taken. I taken from Google. This is upstream side. Okay, so you know about upstream side and the downstream side. Okay, so you can see in this picture. So this portion is called upstream side, US upstream side, and this portion is called a downstream side, DS. Okay, so before notch, okay, that portion is called upstream side. After the notch, that means water flowing from upstream side to downstream side through this notch. Okay, this portion is called downstream side. And this portion is the upstream side. Next, discharge over a rectangular notch or weir. So why I shown this picture means, so if you understand the concept of the notch, what is my notch and for what purpose they used practically, means we can easily understand the derivation. Okay, and derivation, and we can easily calculate the actual discharge also. Okay, so from this you can understand the practical. So you can see here the channel width is very small. In this picture, the channel width of the channel is very small. Okay, after that, a notch is constructed along the channel. Okay, so when water level is raised in the channel, automatically it will flow after the it will flow above the crust level of the notch. Okay, from that we can measure the capital H. So there will be a scale is there, but here it is hidden. So there will be a scale. Okay, a scale is better in this end. So from that scale we can easily calculate at the head of the water. So once you find the head of the water, we can easily calculate the theoretical discharge. So if we know the theoretical discharge and positional discharge of this type of notch, we can easily calculate the how much discharge is flowing in that channel. Okay. So you can see in this picture, same picture, the cross section. This is the cross section of the notch, rectangular notch. The expression for discharge over a rectangular notch or weir is the same. Okay, so this point is very important. See, both notch or weir serves same purpose. Only the difference is the shape and size. Okay, so both rectangular notch or weir, the purpose is same. Discharge formula is same. There is no change. So assume a rectangular notch. This is the crust level, and an axis. This is the capital H. That means head of water. So from this head of water, I taken a small height. It means small thickness in that is called DH. Okay. So consider a rectangular notch or weir provided in a channel carrying water as shown in figure. H is equal to head of water over the crust, and L is the length of the notch or weir. This is the length of the notch or. For finding the discharge of water flowing over the notch or weir or notch, consider a elementary horizontal strip. Okay, this elementary horizontal strip is nothing but the DH, a small thickness. Okay, of water of thickness DH. They have taken a small DH, small thickness DH, and the length L at a depth H from the free surface of water as shown in figure. Okay, so the area of strip is nothing but, so what is the here you can observe here a black strip is there. Okay, how to calculate this area since it is rectangular shape? So length into breadth. Here breadth is nothing but dh, length is L and breadth is dh, so L into dh, and the theoretical velocity of water flowing through the strip is equal to root 2 g h. This is the theoretical velocity. It's already be seen in the pitot tube. Okay, so always the theoretical velocity is nothing but root 2 gh. Okay, so the discharge dq here, the discharge meaning is theoretical discharge. Okay, theoretical discharge is equal to, sorry, not theoretical discharge, actual discharge. So here dq is nothing but actual discharge. So dq is equal to cd into area of strip into theoretical velocity. So this area into velocity, what is the area into velocity is nothing but discharge. So here I am multiplying theoretical velocity. So this portion is q theoretical. So this is the q theoretical. So actual discharge. So CD into L into DH into root 2 GH. This is the formula. So area of the strip we already found L into DH, and the theoretical velocity is root 2 GH. CD is the coefficient of discharge of the notch. So now the total discharge Q is equal to, that means Q actual. Here Q is nothing but Q actual. So now I am integrating for the whole notch of weir or weir is determined by integrating the equation 1 between the limits 0 to h. Okay, so we taken a small dh, but we have to integrate from the entire height. Okay, from crust level, that means 0. Crust level is 0, and that thickness of the water is capital H, head of water. Okay, So I put the limit of 0 to h. So CDL DH into root 2G H. Here the only variable is H. Okay. So integral of 0 to H CDL root 2GH equal to into DH equal to CDL into root 2G. So these are the common terms I taken outside. So integral 0 to H into H power 1 by 2 into dh. So what is this h power 1 by 2 is nothing but root h. Okay, root h and h power 1 by 2 is both same. So I am integrating only this variable parameter. So h is the variable parameter here. So CDL into root 2GS is the common term. You can take as it is. So only you integrate this variable parameter. Okay. So if you integrate means h power 1 by 2 plus 1 divided by 1 by 2 plus 1 limit 0 to h. So from this CDL root 2G h power 3 by 2 divided by 3 by 2 h limit 0 to h. So finally we got an answer Q actual which is equal to 2 by 3 CDL into root 2G h power 3 by 2. So this is the formula. So C 2 by 3. So how you got this 2 by 3? So here in the denominator 3 by 2 is there. If you go to numerator means it is 2 reverse. That means reverse means it is 2 by 3 only. 3 by 2 reverse means 2 by 3. So 2 by 3 CDL root 2G h power. So here h is come here. So h power 3 by 2. 3 by 2 is nothing but 1.5. Okay, 2 by 3 CDL root 2G h power 1.5 is the Q actual formula. Okay, so I hope all of you understand this derivation. This is an important derivation. So now we will see the problem using this formula. So find the discharge of water. Find the discharge of water flowing over a rectangular notch of 2 meter length. Here 2 meter length is nothing but L. Okay. So when the constant height over the notch is 300 mm. Constant height is nothing but capital H and CD value. So in this problem, CD value is given. It is 0.6. So now what is the what are the parameters they asked? Only the discharge. So Q actual is nothing but 2 by 3 CDL root 2G h power 3 by 2. So 2 by 3, what is CD? It is given in the question, it is 0.6 into L. L is nothing but 2 into root 2 G. G is 9.81. Since we are substituting all the values in terms of meter. So here one small mistake is that this is not meter. It is correct. It is mm. It is mm. Okay, it is mm. So 300 mm, if you convert it into meter, means 0.3 meter. Okay, so substitute root 2G, G is 9.81 into H. H is nothing but it is 0.3 meter. So substitute H is equal to 0.3 power 3 by 2 is 1.5. 3 by 2 or you can put 3 by 2 as it is. Okay, so finally we got value 0.582 meter cube per second. So this is the discharge formula. Discharge unit is meter cube per second. For 1 second, how much quantity, that means how much volume of water is delivered through the notch. Okay, that is the meaning. Meter cube per second. It is 0.52 meter cube per second. So this is the basic fundamental formula. Okay, simple. Once you know the formula, you can directly substitute. Okay, because all the data is given. CD value is given, length of the notch is given, and H value. That means head of the water also given. So let us move to the next problem. So next problem is very important problem. So this is the 10 mark problem. So please listen. So I read the question. Determine the height of a rectangular weir. So this is not notch, this is weir, but formula is same. Rectangular weir of length 6 meter to be built across a rectangular channel. The maximum depth of water on the upstream side of the weir is 1.8 meter and the discharge is 2000 liters per second. Take CD is equal to 0.6 and neglect end contractions. Okay. So in this problem, they didn't give the head of the water. Okay, they didn't give head of the water. What they given means maximum depth of water in the upstream side. Okay, you can see in this picture, this is the cross section of that weir. This is the crust level. So this is the water is flowing. So the H1 value is given. H1 value is nothing but the 1.8 meter. Okay, this H1 value is 1.8 meter and H value not given. And what they are asking, what is H2? What is H2? So first understand the question. What they given, what they asking. Okay. So the maximum depth of water, this line is very, very important. The maximum depth of water on the upstream side of the weir. Okay. So this is the maximum depth of the water in the upstream side. This is your upstream side. Upstream side and this is your downstream side. Okay. So in that upstream side, the overall depth of the water, flowing water is 1.8 meter. Okay, so that here I mentioned H1. So it is 1.8 meter. So this capital H value we don't know. That means head of water above the crest level. And they asking what is the height of the weir. That means H2. So let us see. So if you found this H means this H1 minus H. Okay, H2 is equal to this H1, because H1 value is given. So this H1 minus H is the answer. So first thing we have to find this H. So how to find? We know all the values. Okay, even discharge also given. So now what are the given data? Length of the weir 6 meter, depth of water H1 1.8 meter. So in this problem, first you draw the figure. If you draw the figure means the problem is very easy. Okay. Next, the discharge is 2000 liters per second. So here they given in liters per second. Don't put as it is. You must convert into meter cube per second. Meter cube per second. So 2000 divided by 1000. So 1 meter cube is equal to 1000 liters. So it is 2 meter cube per second. CD is equal to 0.6. Okay. Let H is the height of the water above the crest of weir. Let H is the height of water above the crest of the weir. And H2 is equal to height of the weir. Okay. The discharge over the weir is given by the equation. So what is the equation for discharge? Q is equal to 2 by 3 CDL root 2 G H power 3 by 2. So this is the formula we already know. So here what are the data given? Q is given. It is 2 meter cube per second. And the CD value given. What is CD value? It is 0.6. And the length also given. It is 6 meter. Here 6 meter. And the unknown value is only capital H. Okay. So we need that H only. So now substitute all the values Q, C, D, L, G, everything. So we can get the capital H easily. Okay. So from this equation, capital H is equal to 0.328 meter. So this value is 1.8 meter and this value is 0.328 meter. 0.328 meter. So now tell me what is H2. So 1.8, this is 1.8 minus this 0.328. So this is the final answer. We got 1.472 meters. So this is the answer. 1.472 meters. This is the height of the weir. Height of the weir. Okay, that H2. Required height. Okay. So this type of problem is very much important. This type of problem only they will ask in the examination. Okay. So we'll move to the next problem. The head of water over a rectangular notch is 900 mm. Okay, the head of the water over a rectangular notch is 900 mm. So what is head of water? Capital H. Okay. Next, the discharge is 300 liters per second. 300 liters is nothing but, if you convert it into meter cube per second, means what is that? It is 0.3 meter cube per second. Okay. So what they asking? Find the length of the notch. Find the length of the notch. So they asking the length L. Okay, and CD value also 0.62 also given. So first write the given data. So H is equal to 90 centimeter or 900 mm. You must convert it into meter. It is 0.9 meter. Next, discharge Q is equal to 300 liters per second. You must convert it into meter cube per second. So again and again I'm telling, so don't put liters per second. So in the examination they will give liters per seconds only in the question. Don't put as it is. If you put as it is liters per seconds, means it is wrong. You must convert it into meter cube per second. That is the first step. You can see in every problem. Okay, so if they given liters per second, means you must they convert it into meter cube per second only. So or otherwise, if they given meter cube per second directly, means no problem. Okay. So next, let the length of the notch is L. Using the equation, we have Q is equal to 2 by 3 CDL root 2 GH power 3 by 2. Okay. So now Q is equal to, what is Q? 0.3 meter cube per second. And CD value is 0.62. And length only we don't know. Okay. So keep as it is. And root 2 G. G is 9.81. And H power 3 by 2. What is H? What is H? 900 mm. If you convert it into meter, it is 0.9 meter, 3 by 2. Okay. So now substitute all the values. We can easily get L length is equal to 0.192 meter. Okay. If you convert it into mm, means it is 192 mm. Okay. 192 mm. Very, very small. Very small length. Okay. Since it is notch, it is not a VR, it is notch. Okay. It is it's made up of a metallic plate. So previously we seen rectangular weir. Weir is the huge length. Okay, you can you also seen the length of the weir is 6 meters. But here notch, so length will be very, very small only. Okay, so this is the another problem, type of problem. So next, so far we seen rectangular notch and weir. So next, triangular notch or weir. Okay. So in this, compared to rectangular notch and weir, so the triangular notch and weir derivation is somewhat critical because it is varying cross section. You can see here in this triangular notch, you can see here. So the shape is not a constant. Okay, here the cross section is different. Again, it is keep on increasing. Okay, the shape is keep on increasing. That means the width of triangular notch is keep on increasing. So we must know the fundamentals to derive the discharge over a triangular notch. Let us see the problem. So the expression for the discharge over a triangular notch or weir is same. It is derived as, let H is equal to head of water above the notch. You can see here, this is the sill level. This O point is there, that is called a sill level. And head of the water above the sill level or crust is a capital H. Okay. And theta is the angle of the notch. You can see here theta. So this theta, this included angle of the V notch is called theta. So let us start the derivation. Consider a horizontal strip of water thickness dh. So now I am considering a small strip. This is called a dh. Okay, in that notch at a depth of h. Okay, So the center point of the strip is located from smaller h from the water, from the free surface of water as shown. Okay, from this triangle tan theta by 2. So you can see here, this is the triangular section, a smaller triangle. So I won't take two triangular. There are two triangular is there. So I won't take two triangular at a time. I'm taken ACO. Okay, you can see here where A is there, here A is there, and this midpoint of the notch is C, and the crust level is O. So I'm taken only this triangle. So ACO. Okay. So tan theta by 2. Okay, what is the tan theta? What is by tan theta? Opposite divided by adjacent. That means AC. This AC divided by OC. So this is the tan theta. So AC we don't know. So keep as it is, and OC. What is OC? OC is nothing but capital H minus this small h. So capital H is nothing but head of the water, and small h is nothing but the from the free surface, the depth of the strip is small h. Okay, that is called OC. From this equation, what is AC? So this capital H minus small h into tan theta by 2. Okay, so H minus capital H minus small h into tan theta by 2. So keep as it is. Now width of the strips AB, width of the strips AB is equal to 2 times of AC. Okay, because it is a symmetrical section. This is the midpoint. AC equal to CB. So this is the 2 times of AC. AB is equal to 2 times of AC. So now AB is equal to 2 times of AC. What is 2 times? 2 into capital H minus small h into tan theta by 2. So now area of the strip. So I am taken a small strip. I am taken a small strip in this notch. So how to calculate this area? So AB into this DH. Since it is a rectangular, so AB length, this is the AB length into this small thickness. So what is AB? It is 2 times of H minus H into tan theta by 2 into this small DH. The theoretical velocity of water through the strip is root 2 GH, we already see. Now discharge through the strip. dq is equal to this, the actual discharge. dq is equal to CD into area of the strip into velocity, theoretical velocity. So CD into, what is the area of the strip? We already found here. 2 times of capital H minus small h tan theta by 2 into dH. Okay. Into theoretical velocity is nothing but root 2 GH. Now I am simplifying. 2 into CD, H minus H, tan theta by 2 into root 2 GH into DH. So now I am integrating from 0 level to capital H. Okay, that means that crust level to at the free surface of the water. So 2 into CD, H minus H, tan theta by 2 into root 2 GH into DH. Okay, next. So you can see here, only the variable thing is H term. That means capital H minus small h term only. So the common term I can take outside of the integration. So 2 CD tan theta by 2 into root 2g integral of 0 to h capital H minus small h into h power 1 by 2. H power 1 by 2 into dh. So simplify this equation, 2 CD tan theta by 2 root 2g integral of 0 to h. So I am multiplying this h into this h. That means this h into this h and this h into this h. Okay. Next, 2 into CD tan theta by 2 into root 2g. So now integrate with limit 0 to h. So here in denominator in this portion 3 by 2 is there. 3 by 2 will come, and here 5 by 2 will come. So next is this 3 by 2 will come outside, means it comes into 2 by 3 minus 5 by 2, it is converted into 2 by 5 h power 5 by 2. So again if you simplify again 2 by 3 minus 2 by 5. So these are all here h into h is there. So h into h power 3 by 2. You can see here only h by 5 by h power 5 is there. Here h into h power 3 by 2 is there. Okay, so now it is turned into h power 5 by 2. So here also h power 5 by 2 is there. Here also h power 5 by 2 is there. So what is 2 by 3 minus 2 by 5? It is nothing but 4 by 15. It is nothing but 4 by 15. So here 4 is there. Here 2 is there. Okay, here 4 is there, here 2 is there. So 4 into 2, it is nothing but 8. And this is the 15 into CD tan theta by 2 root 2g into h power 5 by 2. So this is the formula for the triangular notch or V notch. So there are two names. First one is triangular notch or V notch. Okay. So for right angle to triangle V notch. Okay. So what is a right angle triangle? Means the included angle is 90 degree. So the normally the triangular notch angle included angles will vary from 45 degree, 60 degree, and 90 degree. So in case of 90 degree means this tan theta by 2. Okay. So tan 90 by 2. What is tan 90 by 2? Tan 45. Tan 45 value is 1. Okay. So substitute in this one here. This tan theta by 2. In case of theta value is 90. Okay. So substitute value 1 here. So same thing here. Substitute 1 instead of tan theta by 2. So finally we got, if you simplify the equation means Q actual is equal to 1.417 h power 5 by 2. 1.417 h power 5 by 2. In case of the angle is 90 degree. If some other angle means you have to use this formula. Okay, even 90 degree also you can use this formula. So why I am telling this formula means this is very easy formula, easy to memorize. If you simplify means if you put tan theta by 2, the theta value 90 degree means you can get this formula. Either you can memorize this one or otherwise this is the common formula. This is applicable for all angles, either 45 degree, 60 degree, 50 degree or 90 degree, whatever it may be. If you put the angle here in this formula means you can easily got the answer. Okay. So this is the cross section of the triangular weir. You can see this is the 3D view. So water is flowing and from the upstream side to downstream side through the triangular notch, and this is the included angle. This is the height is nothing but the head of the water. Okay. You can see here in this picture. So you can see this is the notch. Okay, this is the notch. So a plate is attached in that construction. Okay, so through this plate water is flowing. Okay, from the, this is the upstream side, this is upstream, and this is downstream. Okay, this is down. So from the upstream side to downstream side water is delivered. Okay. Now you can see here in this upstream side there is a scale is there. Okay, so using this scale bottom, that means zero level and the crust level both are same. Okay, so this is the water is flowing above the crust level. We didn't see the exact crust level. So this crust level, suppose if you take the crust level here means crust level, this is the crust level means, so the scale is started from the crust level, so that we can measure the height of the head of the water. That means the capital H. Okay, so with the crust level means this is the your capital H. So using this scale we can easily find the head of the water. Okay, this is also another view of the triangular notch. So this is also a small channel. From that channel, a triangular notch is attached. So through this notch, water is flowing. Okay, now continue the problem. So now all of you understand the, I think understand the derivation and the concept of the triangular notch, and we also seen some of the live picture. Now we will discuss the problem. Find the discharge over a triangular notch of angle 60 degree. Okay, angle 60 degree. When head over the notch is 0.3 meter. Assume CD is equal to 0.6. Okay, so here theta is 60 degree and capital H is nothing but 0.3 meter and CD value is 0.6. Okay, so the Q discharge, that means Q actual discharge formula. We know that 8 by 15 CD tan theta by 2 into root 2G into H power 5 by 2. This is the formula. Please be remembered. Okay. So what they asking, find the discharge. So Q value. So substitute all the values. CD value is given, theta value is given, H value is given 0.3. Okay. So finally we got substitute all the values. Finally we got an answer 0.040 meter cube per second. 0.040 meter cube per second. This is the simple basic formula. Okay. So next problem, I'll read the question. Water flows over a rectangular weir 1 meter wide at a depth of 150 mm and afterwards passes through a triangular right angled weir. Okay. Take CD for a rectangular and a triangular weir as 0.62 and 0.59 respectively. Find the depth over the triangular weir. So student, first understand the question. So in this question, there are two types of weirs there. First one is a rectangular weir and a triangular weir. So initially, yes, some distance, a rectangular weir is constructed. Okay, first water is flowing from the channel, water is flowing. First it crossed the rectangular weir. Okay, so next afterwards, after some distance, say 10 meter or 20 meter after that, yeah, triangular weir also constructed. Okay, so in that same channel, there are two types of weirs are constructed. Okay, so the rectangular weir length is 1 meter and the depth is 150 mm. And first initially water is flowing from the rectangular weir. So after that it crossed rectangle triangle weir. Rectangular triangular weir. Okay. So that triangular weir and rectangular weir, rectangular weir and triangular weir CD value, quotient of discharge value is 0.62 and 0.59 respectively. Okay. So data given, length 1 meter, capital H 0.15 meter, CD 0.62, theta 90 degree and CD 0.59. So this portion is for rectangular weir and this is for triangular weir. So what they are asking, let the depth of the find depth over, that means head of the water. Okay. So now assume the depth over rectangular weir is H1. Okay, the discharge over the rectangular weir is good. So once you understand the question, one data is missing. What is the data? Is nothing but discharge. So without discharge, how you found H? For that purpose only, they given indirectly. Discharge is given indirectly. How? Let us check. So first, water is flowing from the rectangular weir. So first we need to calculate the discharge using this rectangular weir. So what is the discharge formula? 2 by 3 CDL root 2G H power 3 by 2. So CD value is given 0.62 and length given 1 meter and capital H is given 0.15. Okay. So from this the answer is 0.10635 meter cube per second. So this is the answer. This is the discharge in that open channel. Okay. So the same water, same discharge is crossing the triangular channel also. Okay. So I will draw the cross section. Sorry, plan of that concept of the problem. So you can see here, this is the channel. So water is flowing like this. Water is flowing. Okay. So initially, a rectangular weir is constructed. A rectangular weir is constructed. So after some distance, a right-angled triangular weir is constructed. So same water only flowing from rectangular and triangular. So discharge is same. Whether it flowing or rectangular or triangular, discharge is same. Okay. So first to calculate the discharge. So of the rectangular through the rectangular weir. So same discharge only traveled in triangular notch also. So discharge is same. So once discharge is found, substitute the same discharge value. The same discharge, you can see here, the same discharge passes through the triangular right angled weir. But discharge Q is given by equation 8.2 for a triangular weir is Q is equal to 8 by 15 CD tan theta by 2 into root 2 G H power 5 by 2. So Q value is given 0.10635. So you can substitute Q value the same value because discharge is same. So 8 by 15 into CD. CD value is given for triangular section is 0.59 and theta is right angled triangle. So it is 90 degree and root 2 G H. Okay, here H is equal to H1. I taken H1. Otherwise you can keep as it is H. That is your wish. Okay, so substitute all the values. Okay, so finally you got in terms of the discharge is equal to, that means 0.10635 is equal to 1.3936 H1 power 5 by 2. Okay, so from this equation you can find the H1. So H1 power 5 by 2 is equal to 0.10635 divided by 1.3936. So finally H1 is equal to 0.3572 meter. So this is the answer. So from that V notch, this is the head over the notch, crust level. So water is flowing like this. Okay, like this. So this height is the final answer we got. Okay, the answer is 0.3572. This is the head over the notch or head of water, H1. H1. Generally, it is mentioned as H. In this problem, they mentioned H1. Okay. So this is the important problem in this rectangular and triangular weir. Okay. So water is initially flowing from rectangular weir at starting. After that, triangular weir. Okay. So next, same type of problem, but here now water is flowing triangular to rectangular. Let us see. Same method. So in previous problem, first we calculated discharge from rectangular weir. But in this problem, first we have to calculate the discharge in terms of that triangular weir. Okay. So concept is same. I read the question. Water flows through a triangular right angle weir first and then over a rectangular weir of 1 meter width. The discharge coefficient of the triangular and rectangular weir are 0.6 and 0.7 respectively. If the depth of water over the triangular weir is 360 mm, find the depth of water over the rectangular weir. Okay, so this is the question. Same method. So first we need to calculate the Q value. Okay, so Q is equal to 8 by 15 CD tan theta by 2 root 2 G H power 5 by 2. So in this, for triangular weir, head of the water is given. But in case of rectangular weir, head of water is not given. For that only we have to form. So 8 by 15 CD value 0.6 tan theta. Since it is the right angle, see here you can see right angle. Right angle means 90 degree. If other angle means, they definitely give the theta value in the question. So root 2 G H. What is H? Where is H is there? Here you can see if the depth of water over the triangular weir. Okay, so we have to use H in this H for triangular weir only. It is 0.36 H power 5 by 2, which is equal to 0.1102 meter cube per second. Next, the same discharge is passing through the rectangular weir, but the discharge for a rectangular weir is given by the equation Q is equal to 2 by 3 CDL root 2 G H power 3 by 2. So here the only unknown value is H. So Q value already we found, it is 0.1102 because same discharge of water only flowing through the rectangular weir also. So substitute all the values. CD value 0.7. Here they given 0.7 L length. Length also given 1 meter. Here you can see in the question 1 meter and root 2 G H power 3 by 2. So from that capital H, substitute all the values. We can get the in terms of Q value in terms of H. That means 2.067 H power 3 by 2. So from this H is equal to 0.1415 meter. If you convert it into mm means it is 141.5 mm. So this is the final answer. So in the examination they will give a rectangular weir after that triangular weir, or a triangular weir after that rectangular weir. So the procedure is same. Once you know the formula means you can substitute, and for first step is you have to find the discharge. After that, the same discharge you have to use the another weir to find the H value. That's all. Okay. So next problem. A rectangular channel 2 meter wide has a discharge of 250 liters per second, which is measured by a rectangular V-notch weir. Find the position of the apex of the notch from the bed of the channel if the maximum depth is not to exceed 1.3 meter. Take CD is equal to 0.62 meter. Okay, so the position of the apex of the notch from the bed of the channel means that crust level is nothing but the crust level. Okay, so now we will see the problem. So width of the rectangular channel is L, 2 meter is given in the question. Q is equal to discharge 250 liters per second. It is converted into meter cube per second, it is 0.25. And depth of water in channel is 1.3 meter. Depth means you can see here. That means upstream side depth. Water is flowing from. So this is 1.3 meter. This is the depth of water in the upstream side. Okay. So next, let the height of water over the notch is capital H. So this height is nothing but the capital H. Okay. So rate of flow through the V notch is given by Q is equal to 8 by 15 CD root 2 G tan theta by 2 into H power 5 by 2. So CD value given, theta value given, right angle triangle. So theta value 90 degree. So substitute all the values. The unknown value is H. Unknown value is H. So H is equal to, what is the H value? It is 0.493 meter. So this H is equal to 0.493 meter. So if you substitute all the values, the only unknown value is capital H only. So from that we can calculate the 0.493. So now I will draw the elevation of this notch. Okay. So this is the water height. So this head over the notch is how much? 0.4 meter, 0.493 meter. Okay. So, but the overall depth of the notch. So, this is the water is flowing here. The overall depth. What is the overall depth? 1.3 meter. Say what they asking? Position of the apex of the notch. Position of the apex is nothing but this point, this O point. So, what is this height? This only they asking. Position of the apex of the notch from the bed level. Okay, this is the bed level. So this is the ground surface. It's also called bed level. BED, bed level. Okay, this is the bed level. So from the bed level, what is the crust height? That means position of the apex. It's also called position of the apex. So how to calculate? So from here to here, that means overall depth of the water is 1.3 meter and depth of the water in that head over the notch is 0.493 meter. So finally the position of the apex from the bed level is nothing but sometimes they will ask what is the position of the crust or position of the sill. All are same meaning from the bed level. Okay. So the finally we got 1.3 meter minus 0.493 meter. So 1.3 minus 0.493, we got 0.807 meter. So this is the answer. Okay. So from the bed level, the notch crust is located at a height of 0.807 meter. Okay. So first read the question, what they asking, okay, what they given. Okay, first you understand. Based on this, draw a diagram. Okay, draw a diagram. From the diagram, we can easily find the what is the solution. Okay. So next, what are the advantages of triangular notch or weir or over a rectangular notch or weir? See, compared to rectangular notch and rectangular weir, there will be some advantages is there. Okay, triangular notch having some advantage. What are they? A triangular notch or weir is preferred to a rectangular weir or notch due to the following reason. This is important 3-mark question. Okay, the expression for a discharge for a rectangular V notch or weir is very simple. Okay, easy to remember. Next, for measuring the load discharge, this point is very important. For measuring the load discharge, because in some case water is flowing in a very small velocity. Okay, so a triangular notch gives more accurate results compared to rectangular notch. So compared to rectangular notch discharge value, the triangular notch discharge value is more accurate. In case of triangular notch, only one reading. That means H is required for computation of the discharge. Okay. So, but in case of rectangular notch, we need 2 values. That means capital H and capital L. Length of the notch also we need. Next, ventilation of a triangular notch is not necessary. What do you mean by ventilation? Ventilation is nothing but that free bore. Okay. So for triangular notch, it is not required. Okay. So up to this rectangular notch and a triangular notch over. So next class we will discuss the trapezoidal notch. Okay, trapezoidal notch is a combination. We know the shape of the trapezoidal. The bottom width is somewhat small compared to the top width. Okay, it is like this shape. Okay, it's like this shape. So it is a combination of both rectangular notch and triangular notch. So in the derivation also, if you add both rectangular notch and triangular notch formula, we can get the trapezoidal notch formula, discharge. Okay, we know that rectangular notch formula, you know the triangular notch formula. You add these 2 formulas. That is the formula for the trapezoidal notch discharge formula. Okay, that we will discuss in the next class. So I hope all of you understand this triangular notch and rectangular. It is very easy sum only. Okay, derivation also very easy. In some cases in the examination, they definitely ask derivation also. Okay. Okay, thank you students. We will meet next class.